let's just get straight to it. Liquids. All right, so we're talking about states of matter here. And liquids, okay, liquids are a big thing. Of course, liquids are used as they're basically required for our life, right? So tons of water solutions we have that are in our body, and then different things that we have to do just for biological reactions, okay, to occur. So it has to be in liquid form. Okay, that's the reason why they're so important. Even on our regular day life, right? Food preparation, you're trying to make anything or cook anything, you gotta make it to a liquid or something like that. Baking it, it could be anything, even a bowl of cereal, right? Milk, that's a liquid. Cleaning, all the different cleaning products are usually in the liquids, etc. Right? A lot of different things are in liquid form. So let's talk about some characteristics of liquids. Now we talked about this slightly when we were going over gases. So we understand that gases are highly compressible, right? They're able to be squeezed down. Now liquids, they can be compressible. Okay, I will say they can be compressible, but usually they're not compressible. They're usually not compressible. It takes a lot to actually compress them. They're not going to be like the gases, right? So they're not non-compressible for the most part. As well as liquids, what do? They take the shape of the container. Okay, so that's another thing they do. They have a set volume, but they can take the shape of the container that they are in. I.e., this example here, this little beaker. This beaker is shaped like a triangle, right? Pour some liquid in there, it's going to take the shape of that triangle. And that's the case for anything. You got a bowl, or if you have a long tube, it doesn't matter. It's going to take the shape of that container, depending on the liquid. And then another thing is that liquids are dense. Okay, so liquids are more dense, I should say, than gases. Okay. Now, when we think about liquids, right, this is water, right, and water is broken down as these molecules here, H2O. Okay, and now we understand we got intermolecular forces attracting between each water molecule, right? If you still got some questions about intermolecular forces, make sure to check out the videos in this playlist. Okay, now let's look over here. Particles in a liquid are closely packed, but they have some ability to move around, and that sums up liquid right there, right? If we look right here, we can see, and that's the key thing when we understand about liquid, is that they're going to have the same volume. They always will have the same volume, and that's because they're packed together closely. Okay, and it's not going to switch in any way, right? This connection that they have. However, even though they are close, compact together, okay, they're able to move around, and this is the reason why they're able to take the shape of any container that they're in, okay, because of this ability. Now, unlike gases, right, just because they are a little bit close, compact together, it's going to cause them to be not as compressible, okay, depending on how hard you do it. But usually, just because of this, they're really incompressible. Right, we got to remember they're different from gases. Now, the reason being, right, they don't have that freedom like gases. Remember, gases just moving around, traveling around, doing its own thing. They're independent in a way. Liquids, they a little locked together. They loosey goosey with it, but they still holding hands like that. So they just not free. They got, we still touching in a way. Okay, and because of this, right, they can't escape containers, right? You're never going to see a liquid escape a container that is put in. If it is escaping, well, that's not a liquid, it's a gas, it's leaving. Okay, so that's the one thing about liquids is just because they do have this closely compact and they're touching each other, right? They're not able to escape or really fill a container, just like as we saw with gases.